Hello everyone, today let's solve the problem number 128. Longest consecutive sequence, right? So what the question states here, we are given an unsorted array of integer nums. You can clearly see here, we are given an unsorted, this one, array of integer nums. You can clearly see here, right? They have said that we are given an unsorted array of integers. This is not sorted, you can clearly see here, right? So we have to return the length of the longest consecutive element sequence. So we shouldn't return the longest consecutive elements. We have to return the length of longest consecutive element sequence. So that's what we need to. So just keep this in mind. Again, I'm telling we have to return the length. Keep this word in mind. We have to return the length of the longest consecutive elements sequence, and we must write an algorithm that runs in at least big of n time. They have asked, right? They've strictly asked this one. So I hope the question is completely clear. Let's come to first example that they have given in the question. So here you can clearly see we have been given 100, 4, 200, 1, 3 and 2, right? So when we sort this, we get 1, 2, 3, 4, 100 and 200, right? 100 and 200. So they have mentioned in the question that we have been given unsorted array of this one, right? Integer nums. So here you can clearly see 1, 2, 3, 4 is the longest consecutive elements. So 1, 2, 3, 4 are the longest consecutive elements here on this case, right? So the length of it is 4. You can clearly see 1, 2, 3, 4, 4 elements we have. So the length of this one longest consecutive element sequence is 4 here in this case. So the output we have to return here in this case is 4. So here they have clearly mentioned in the explanation the longest consecutive element sequence is 1, 2, 3, 4. Therefore its length is 4 as well, right? Same goes with the example 2 here. You can clearly see when we sort this one, we get 0 is present twice here, 0, 0. So 1, 2, 3, 4, 5, 6, 7 and 8 we have, right? So here we will ignore 1, 0 and we will start from 0, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8. Total 0 to 8 we have 9 elements, right? So we need to return this one, 9. The length is 9, so we need to return the number 9 as output. So let's come to the third output here. Nums we have 0, 1, 0, 1, 2, right? When we sort this one, we get 0, 1, 1, 2. So in this case, this one, we can just go for 0. We can just consider one element here. So 1 is, we have duplicate for 1, right? So we'll just consider 1, 1 here and 2. 0, 1, 2. We can consider. So the output that we need to return here in this case is 3. So the length is 3, right? 3 elements, 0, 1 and 2. So this is what we can do. So this is what we have to do. Sorry. Yeah, this is what we have to do. So we can just do one thing here. Let's discuss the approach first, followed by the edge cases, and then write the code and discuss the complexities for the code that we have written, right? First thing you can observe here is we can just go for the sorting and just find the longest consecutive elements and then return its length. But they have asked here to write the algorithm that runs in big of n time. If we go for the sorting, the overall time complexity would be big of n log n, right? So they have clearly asked here to write an algorithm that runs in big of n time, right? So we can just make use of the hash map in this case, right? Or hash set we can make use of, sorry. We can just make use of the hash set in this case. Let's see. Let's discuss the same thing in the approach. So here, let's discuss the approach step by step. The first thing here we need to observe here is we will be going with a hash set approach. So we'll be going with a hash set approach, right? So I have considered the same example, the first example that I have given in the question, so that it will be easier to understand. We have already discussed this one. Here in this case, when we sort this one, we get 1, 2, 3, 4, 100 and 200. So here the longest consecutive sequence here is 1, 2, 3, 4. So the length will be quite obviously 4. We have 4 elements here, right? So that one we need to return. In this case, output is 4, right? So let's discuss the approach step by step here. So we have to write the algorithm on big of n time they have mentioned, right? Let's see how can we do that. So first thing here is we will be converting this one to the hash set. So we will convert to the hash set, means we will store all the numbers in the set. So we have the numbers here in this case 104, 200, 132. These numbers, first thing is we will be storing this one in the hash set, right? Why? Because for the big of one lookup, for the big of one lookup, right? So overall time complexity would be big of n in this case. For each element it will be, we are storing all the numbers in a set for the big of one lookup. So overall time complexity and the space complexity both will be, in the worst case it will be big of n, right? So here in this case we are storing all the numbers in a set for big of one lookup. S equals 100, 4, 200, 132 individual numbers. We are saving this 100, 4, 200, 1, 3 and 2. Let's move on with the second step here. So second step, we will find the starting point. We have to find the starting points, right? So we will iterate through the set and only start a sequence when n minus 1 is not in the set. So this one, just keep this in mind. When n minus 1 is not present in the set, then only we have to start the sequence. In this case, see, we have 100, 4, 200, right? So I'll just write here 100, 4, 200. So this one, just give me a second here. 100, 4, 200, we have 132. So we will check whether the previous number is present for all the elements in this case, right? Previous elements, n minus 1 means 99 is present. If 99 is not present, I mean previous element is not present, then only we will consider it as the starting point. So in this case 99 is not present, we will consider 100 as the starting point, right? So like that we'll be considering. Let's see further step what we will do. So we will expand the sequence, means if n is the starting point, then we will keep checking n plus 1, n plus 2 until it's missing, right? Until it's missing. In this case we have, see, just give me a second, 100, 4, 200, 100, 4, 200, 132. So if n is the starting point, here we'll check previous number is present or not in this case. So 99 is not present, this is the starting point. So next we will check for n plus 1. So here we will check for 101 here in this case. So 101 is not present, we will ignore 100 here. 101 is not present. Same thing we will do for 4 here in this case. For 4, previous element is present, 3 is present, right? We'll check for the next number 5. 5 is not present. So previous number 3 is already present. So we'll not check for the next number at all. So previous number 3 is present. So we'll not check for the next number at all. We will ignore this one as well, right? So next we will check for 200. Sorry, we'll not check for 5 here. Previous number 3 is already present. So we'll ignore it, this one. So here next we will go for 200. We will check for the previous number. Here 199 is not present, right? So next we will check for the next number 201. N plus 1 we have to check for. 201 is not present. 201 is not present, right? 201 is not present in the set. So what we will do, we will ignore 200 as well. Now we have 3 numbers 1, 3 and 2. Now we have 3 numbers 1, 3 and 2. So we have to consider 1. For 1, previous number we will check for 0. 0 is not present in the set. So we will check whether 2 is present. Next number n plus 1, 2 is present. So 2 is present. Here you can clearly see 2 is present in the hash set. So this is fine. This works good. Next we will go for n plus 2. Means 1 plus 2. Here in this case 3. Right? So 3 is present in the hash set. Here you can clearly see 3 is present in the hash set. So we will add the 3 to the set. Next what we will do, we will check for n plus 3 here. Next after n plus 2, n plus 3. This is n plus 3 means 1 plus 3. In this case it will be 4. 4 is present in the hash set. So we will add 4 to the set. So next step here is we will check for the n plus 4 here in this case. 1 plus 4 is 5. So 5 is not present in the hash set. You can clearly see 100, 4, 200, 1, 3, 2 we have. 5 is not present in the set. We have 4 now. We have 4 now, right? So we have 4, 1, 2, 3 and 4, right? So in the set. So this one we have 4. next we will go with the 3, right? For 1, we got until 1, 2, 3, 4. Next, 2 more elements are, we have to check for 2 more elements, right? We will check for 3. In this case, for 3, we will check whether the previous element is present in the set. So 2 is present here. The previous element is present. So what we will do? We will ignore 3 here. In this case, we will ignore 3. The last element is 2. For 2, we will check whether the previous element is present. Yes, 1 is present here. You can clearly see 1 is present in the set. So we will ignore 2 as well in this case. We will ignore 2 as well. So the highest, this one, the longest subsequence, the longest sequence we got here is 1, 2, 3 and 4. You can clearly see here 1, 2, 3 and 4, right? So the longest sequence we got here is 1, 2, 3 and 4, or else the longest sequence we got here is 100, 1, only 1, 200, only 1, right? Here for 100 it was only 1, for 200 it was only 1, for 4, 3 and 2 previous element was found, so we will be ignoring this one. 1, 1 for this one. For 1 we have 1, 2, 3 and 4, right? So this is the longest sequence we got, nothing but 4 in this case, right? So this is the longest sequence we got, 1, 2, 3, 4, and the length is nothing but 4 here. 1, 2, 3, 4 we got, and the length is 4 here. 1, 2, 3, 4, length is quite obviously 4, right? So this we will return this one as the output. This one we will return this one as the output, right? So let's come to the final step here. The maximum sequence that is found is 4. So that's what I said here. The maximum sequence that we found here is 4, right? That we will return this one as output in this case. I hope this is clear. Simple to understand, right? So I hope the approach is completely clear. This is the approach that we will be going with. As we are familiar with the approach, what we will do? We will discuss the edge cases. We will be discussing the edge cases. So let's go with the first edge case here. The first edge case here is for the empty array. So we have considered the empty array here. In this case, we don't have any element inside the nums array, so the output will be 0 in this case. So the length is 0. The length of the longest common subsequence is 0. We can directly write this one, right? The second step, the second edge case here is all elements when all the elements are same, right? So we have 1, 1, 1. Right here. In this case, the longest common subsequence will be the length of the longest common subsequence, this one. The longest sequence of numbers, this one will be 1 itself. So because all the elements are same here, right? So no consecutive sequence here. In this case, no consecutive sequence is found. So the max length is 1. So in this case, no elements are found. So the sequence length is quite obviously 0, right? I hope these two edge cases are clear. Next, let's move on with the third edge case, nothing but already sorted consecutive. Here in this case, we have 1, 2, 3, 4, 5. Already sorted consecutive means they are sorted in the order, right? 1, 2, 3, 4, 5. You can clearly see. So we can just consider this one directly. So output will be 5. The length of the longest sequence is 1, 2, 3, 4, 5 itself, right? In this case. So length will be 5 in this case. So let's move on with the fourth edge case here. Let's move on with the fourth edge case, gaps in sequence. So you can clearly see 10, 20, 30, 40. So every number is distinct here, and we don't have the this one. No consecutive numbers at all here. Every number is distinct in this case, and no consecutive numbers. So each number forms a sequence of itself, nothing but 1 here in this case. Output will be 1 in this case. Let's move on with the final edge case, or the negative, or the fifth edge case for the negative numbers. In this case, we have -3, -2, -1, 0 and 1. So in this case, the longest common consecutive sequence here is 5. So we have -3, -2, -1, 0 and 1, right? So the longest consecutive sequence here is 5 in this case, right? So 5 the longest consecutive sequence is 5 in this case. I hope this is clear. So the first edge case here is empty array. This is fine. The second edge case we discussed for is this one, all elements same. The third edge case here is this one, already sorted consecutive. The fourth edge case here is this one, gaps in sequence. The fifth edge case here is negative numbers. These are the 5 edge cases that we consider, right? So these are the 5 edge cases that we need to keep in mind. So now we are familiar with the approach as well as the edge cases, right? Now it will be easier to it will be easier to write the code. Let's start writing the code. So first step here is we have discussed this one in the edge case. If the array is empty, we have to return 0, the first edge case, right? So let's write the same thing. We have to articulate that one in the form of code. I'll just make use of the simple if condition here. So this one here, if length of the nums, this one, if it is equal to 0, sorry, we are making use of Java right here. This is fine. If it is equal to 0, then what we will do, we will return 0. So let me give here return 0. This is fine. So this is the first step. We have already discussed this one in the edge case, right? So the first edge case, if you remember. So second thing here is we have to store all the elements in the hash set. We have discussed this one in the approach. We have to store all the elements in the hash set for big of one lookup, if you remember. Same thing. Let's initialize the set here. Set integer. So this one variable s I'll consider. We declare here hash set on this case. This is fine. So the next step here is, so let me make this one. So this is fine. Just give me a second here. Yeah. The next step here is we have to insert all the elements into the set. After initializing the hash set, we have to insert all the elements into the set, right? So I'll just make use of for loop here. Int n nums here in this case. So we have to add all the elements, right? Or insert all the elements into the set. I'll just make use of the add property that is provided by the hash, this one, hash set n, right? This is fine. So the next step here is we have to store the maximum length of the consecutive sequence that is found. So out of that one, if you remember in the approach, for 100 length was 1. If for the 200 also, we didn't have the previous element for 100 and 200, right? So that was 1. For when we started with 1, we didn't have the previous element 0 in the this one array, but we had the next element 2, 3 and 4. That was the maximum length, or the maximum length of the consecutive sequence, right? So we returned 4 in that case. That itself, we need to articulate that one in the form of code. So we have to store the max length of consecutive sequence that is found. Initially, I'll initialize max to 0, which is of the type int. So I'll just, which is of the type int. This is fine. So the next step here is we have to iterate through the each unique number in the set. We have to iterate through all the elements, right? We have to iterate through the each unique number in the set. Again, one more for loop here. Int n of s. This is fine. So we have to start a sequence only if n minus 1 is not present. So we have discussed this one. For 100, we didn't have a previous number. N minus 1 was not present. 99 was not present. For 200, previous number was not present. Then only we have to check for the consecutive number or the consecutive sequence of number. The consecutive sequence, right? So for 4, previous number was present. 3 was present in the array. If you remember this, I'm speaking of. For 4, 3 was present in the array. So we ignored 4. For 3, we had 2. So we ignored 3 directly. For 2, we had 1 already in the array. So we ignored this one, 2. So in that case, so if the previous number or n minus 1 is present, then we have to ignore, right? Then we have to ignore. If n minus 1 is not present, then we have to start the sequence. We have to start the sequence. Means if here for 100, 99 was not present, we considered, we check whether next element is not present. 101 is not present. For 200 also we check, because 199 is not present, previous number is not present. We check whether next element is present, next consecutive element is present. Nothing but 201 here in this case. So 201 was not present, so length we consider this one. This length had for 100, the length was 1. For 200, the length was 1. For 1, we didn't had previous number, nothing but 0, but we had the consecutive elements, right? Consecutive elements, 2, 3 and 4 we had in the array. So we considered the length 4. That was the maximum. 1, 1, 4 we got length. For 100, 200 and 1, 2, 3, 4. Right? So 4 was the maximum longest maximum or longest consecutive element sequence that we found. So we returned 4 in that case, right? So that's what here we have to start a sequence only if n minus 1 is not present in that case. So how can I write that one in the form of code here? I'll just make use of simple if condition here. If not of s dot contains of n minus 1, then what we will do, we will initialize the sequence length. We will initialize the sequence length. I'll just give here length equals 1 in this case, right? So next we have to count the consecutive numbers, right? So here we have initialized length to 1. So if we find the consecutive number, if we find the consecutive number, then we have to increment the length by 1, right? Then we have to we have to count the consecutive numbers, and if the next consecutive element is found, then we have to increment the length here, right? So how can I write that one in the form of here? So I'll just go with while s dot contains n plus length. N plus length means next consecutive element. If we have found that one, so we have to increase the length. So I'll just give here, let's increment the length by 1, right? So next we have to update the maximum sequence length that is found. So for that I'll just make use of max here. In this case, math.max of max comma length, right? So we have to update maximum sequence length that is found so far. Finally, we need to return the longest sequence length, right? So that is simple. I'll just come here in this case. Let's return max. So this is it for the code. Simple, right? So let me hit the run button. So I hope this works. Let's see. We are getting error. So yeah, semicolon I have missed. Where is this one? Yeah, let me give semicolon here. So let me hit the run button again. I missed semicolon anywhere. Oh, yeah. You can clearly see here the sample test cases are getting passed. Let me hit the submit button quickly. So here you can clearly see all the test cases are getting passed. Means the code that we have written works absolutely correct in this case, right? So let's quickly discuss the complexities for the code that we have written. Right. So first thing here is the approach that we went with here is hash set, right? Or we can just we can just call hash set or hash set based consecutive sequence expansion. We can in simple words we can just say we went with a hash set approach, or we went with a hash set approach. So what would be the time complexity here? The overall time complexity would be big of n in this case. Why it is big of n here? Because it takes big of n to insert elements into the set. So it takes big of n to insert elements into the set. Also big of n to iterate through the set. Individual elements, we have to iterate through the individual elements in the set, right? So it takes big of n to iterate through the set and check the consecutive elements, right? So big of n to insert elements and big of n to iterate through the set, it will be big of n plus big of n total. So overall time complexity we can just consider as big of n itself, right? So what will be the space complexity then? The space complexity or the overall space complexity would be big of n as well. Why? It is big of n for storing the set, and it is big of 1 for the extra variables. So overall space complexity would be big of n itself in this case, right? So the time complexity and the space complexity for the code that we have written is big of n, right? I hope this is clear, and I hope whatever the code that we have written is completely clear as well, right? For now, this is it. Thanks for watching, guys.